or solve each system by graphing. When we solve by graphing, remember, you just graph the two lines and you see where they do what? Where they intersect, and where they intersect is our answer. So that is what we are going to do here. We are going to graph these two lines and we are going to see where they intersect. So for this first equation, we have y equals -1/2 x plus 3. Refresh our memory, guys. When you graph something like this, what do you graph first? Where should I put a point if I see y equals -1/2 x plus 3? Very good. This 3 is our y-intercept. So that tells us we need to put a dot on the y-axis. Oh, wow, that is glitchy. Hold on. What is happening? We need to put a dot at 3. I'm not sure. Let's see, maybe it might just be that spot on my computer. There we go, that's better. Okay, so you're gonna put a dot at 3. Then this -1/2 is our slope. Someone other than Annalise, who can remind us how you count out a slope? Like, how would you count out a slope of -1/2? Yeah, rise over run. So if I have -1/2 or -1/2, do you guys think I should count up or count down? Down. Down how many? 1. And because that's the -1 part, and then your run is 2. So I'm going to count down 1 and then over how many? 2. So I'm going to count down 1 over 2 and put a dot there. Count down 1 over 2. What should I do if I can't count down and to the right? Yeah, you would just do the exact opposite. Instead of going down 1, right 2, you would go up 1 and then left 2. And that does the same thing. And then connect that. And there's your line, except, maybe grab a straight edge. I don't think, does this have a line tool? Is that what this is? Can I draw a line? No, that's just me expanding it. Okay. No, I don't think I can do like a real line with this. That's very bad. But you get the idea. All right. So then let's graph the other line. We have -4x minus 4. So for this one, what do I plot first? What is my y-intercept? Okay, good. So -4. So I'm going to put a dot at -4. Somebody else, what's my slope? Yeah, -4. Good. So if I want to count a slope of -4, do you guys think I should count up or count down? Down. Down how many? 4. And then right how many? 1. Yeah, exactly. When it's a whole number, you count down that many and then over 1. Now, can I fit counting down 4 here? No. So instead of counting down and to the right, I should do what? Up and to the left. Good. So I'm going to count up. 1, 2, 3, 4, left, 1. And then do it again. 1, 2, 3, 4, left, 1. And that shows me where my lines cross. So this point here, where my blue and my red line intersect, is my solution. So can someone tell me what coordinate point that is and how I would write it? Very good, -2, comma, +4. Does this part sound familiar, guys? I feel like we did well with this when we were doing it. Okay, so then let's look at number 2. We have our first equation, y equals -x plus 4. Somebody I haven't heard from or that I've heard from less, what would my y-intercept here be? Oh, come on, guys, we just did it over here. What would my y-intercept be in -x plus 4? Yeah, 4. Oh, did you? I couldn't hear you. All we heard was the part. That's okay. Okay, so it's 4. So put it down at 4. And then this part sometimes throws people off. If I just have a negative in front of the x, what number is technically there? What kind of a one? A -1. Can somebody tell me how I could count out a slope of -1? Yeah, go down 1, right 1. Down 1, right 1, and you can do that as many times as you want. Personally, I think the more points the better, because then you'll be able to clearly see where everything intersects. And if you couldn't do that, do the opposite. Up 1, left 1. And then you can connect these. That's a better line. I have to do it in sections. That's the trick. So there's my one line. Then let's look at this next one. We have y equals 4 over 3x minus 3. So somebody else, what is my y-intercept for this one? What is it? I'm sorry. Oh, yeah, that would be my slope, Alex. So this part's my slope. So we do that second. First, we just got to figure out our y-intercept. -3, but yes. Yeah, it's just -3. So put a dot at -3. And then, yeah, we'll count out our slope. Since it's positive 4/3, we count up 4. 1, 2, 3, 4, right 3. 1, 2, 3. And then actually, even once you've just done that one point, can we see where they're going to cross? Right, and then there, I can see where they intersect. And can someone tell me how I would then write my answer? Yeah, that sounds good so far. 3, comma, and then how far does it go up? 1. Yeah, so 3, comma 1. Good. All right, question for you. What if you're graphing something and it ends up looking like this? You end up with 2 parallel lines. Who remembers what you say for something like this? They are technically linear, but like, are the lines ever crossing in this situation? No. So does anyone remember what we say if the lines don't cross? What'd you say, Asia? They do have the same slope. That's true. No, there's something else. Here, our lines crossed, and where they cross, that's where our answer is. If our lines don't cross, are we going to have an answer? Yeah, we say no solution for something like this. If our answer is where our lines cross, right? If our lines never cross, then it's not going to have a solution. I'm writing this down because this shows up, okay? Just a heads up. So if you see something like this, just say no solution. Does that make sense, right? If where our lines cross is our answer, if they don't cross, is there going to be an answer? No, yeah, no. Okay. So now let's refresh our memory on some substitution. Okay, so this is that thing we did the Google activity for. So remember, if you're substituting, and your test will clearly say to do substitution. Okay, so maybe let's write a note so you have this. This is your 5.2 notes. So if you need to go back, this is your 5.2 notes. So if we are substituting, we are literally taking one equation and plugging it in place of the other. Does anyone remember, if they both equal y, how we start a problem like this? No, nobody quite remembers. So they both equal y, don't they? So if they both equal y, then what you're going to do is select one of your problems, and this is what y equals. This is its value. So if that's what y equals, you're going to take it and plug it in where you see y in the other equation. Well, take a look at the top equation. Where do you guys see y in that equation? Yeah, the very beginning of it. So what we're going to do is we're going to take this and plug it in at the very beginning of the equation. So on that side of the equation, it's no longer going to be y. It is going to be negative 5x minus 8. This y disappears and becomes whatever its value was in the other problem. So negative 5x minus 8. Then on the other side, we just keep that side normal. It's 8x plus 5. Okay, now, isn't this something we can just do our two-column method for? Yeah, so that's what we're going to do now. Should negative 5x stay or go? Stay. What about the negative 8? Go and become positive. Now we're on the other side. What about the 8x? Go and become negative. And what about the 5? It's going to stay. Then we can combine our like terms. Negative 5x minus 8x is negative 15x equals 13. Oh, wait, sorry, I added wrong. Negative 8x, negative 5x minus 8x is negative 13x. My bad. Then what do we do? What's our last step for this part? Yeah, very good. Divide by negative 13. What's a negative divided by a positive? Well, or a positive divided by a negative, either way. No, a positive when you have one of each, it's actually negative. So a positive divided by a negative is a negative. You guys can always plug this into your calculator, don't forget. So that's negative 1. Now that I know what x is, how do I use that to find y? This part's the same no matter what the problem is. Yeah, I know what x is, so I can go and substitute it in anywhere where I see x. So I'm going to plug it into that top one. So this is going to become y equals 8 times x, which we found to be negative 1, plus 5. Then I can just simplify. 8 times negative 1 is negative 8, plus 5. Combine your like terms is negative 3. And then who can tell me how we write our final answer for a problem like this? Yeah, coordinate point. It would be -1, -3. Good. Make sure you have this written down so you can use it tomorrow. All right, number 4. So for number 4, this one's a little different. Instead of having them both be y, one equals y, and one's just another equation. So what you're going to do, if one of them is y, take the one that is y, and we are going to plug it in. We're going to take what our y is, which is -x plus 6, and we're going to plug it in where we see y in our other equation. So turn this into a little fill-in-the-blank type thing. This bottom equation is going to become 3x plus 5 times, put your blank set of parentheses, equals 8. And then who can tell me what we're plugging into that set of parentheses? Right, -5x plus 6. And then we can distribute and simplify. So I'm just going to drop down my 3x, and then I'm going to distribute my 5. So 5 times -5x is -25x. 5 times 6 is 30, equals 8. And then we can do our 2-column method. Should 3x stay or go? Stay. Somebody else, -25x, stay or go? Stay, good. Somebody else, 30, stay or go? Go, become negative, and then the 8. Stay. Combine your like terms, break out that calculator if you need to. Do not try to do this in your head if you struggle with negatives. Remember, there is a calculator available on your computer. If you go to the search bar, just type in calculator, and that's really nice for just some of those little calculations. So 3 minus 25 is going to give you -22x, and -30 plus 8 is also going to give you -22. If you end up with numbers that don't divide properly, that should be a big sign that you did something wrong. So now we're going to divide both sides by -22. And ladies and gentlemen, what's a negative divided by a negative? Good, so this would be +1. 22 divided by 22 is 1. Now that we have what x is, what can we do with it to find y? This is the same for all the problems. Oh, I just said, now that we know that x is 1, where could we put that to find what y is? Sure, you could plug it in there. Could you plug it into the top one too? Yeah, I don't care. Yeah, plug it into whichever one you think looks easier. Just make sure you plug it in for the letter x. So that's what we're going to do here. We have y equals -5 times x, and x is actually 1 now. And then minus, is it a minus or a +6? I drew over it. No, I don't know. It's a plus. And then simplify. -5 times 1 is -5, plus 6, and -5 plus 6 is 1. And then write your answer as a coordinate point, 1, 1. This will give you a really nice example to follow along with both kinds of substitution problems that are going to happen. Okay, there's only going to be 2 of them, probably one like 3 and one like 4. So this should hopefully give you steps to follow. All right, let's look at number 5. And also too, if you need to go back and review any of this in SRT, I'm recording this so you can go back and watch. So now this one says to do elimination. So this time we want to look for things that cancel out. This is your 5.3 notes. So if you take a look at number 5, do we have anybody that's going to cancel out? Yeah, very good. The x's. Negative x and a positive x are definitely going to cancel. So those are gone. And then just combine your like terms vertically. Negative 3y minus 6y is going to give you negative 9y. And then 1 and 26 is going to give you 27. Then what would you do? Yeah, divide by negative 9. And we would have y equals a positive divided by a negative is a negative. Negative 3, exactly. Now that we know what y is, what can we do with it? Yeah, we do. Yeah. Do I care where, Hayden? No, as long as it's in for the right letter, right? I'm actually going to do the bottom one. I know it has bigger numbers, but aren't there less negatives? And I always think less negatives are nicer. So I'm going to take this negative 3 and I'm going to plug it in for where I see y in that other equation. So that's x minus 6 times y, but y is actually now negative 3 equals 26. So then I'm going to simplify. Negative 6 times negative 3 is positive 18. So x plus positive 18 equals 26. And then you can either do your 2 columns, or the only thing we got to move over is that 18. So you could also just subtract 18 from both sides. And you have x equals 8. Okay. We are pretty much out of time right now.